I grew up as an atheist. I used to believe in long ages and evolution because that's what I was taught to believe.
What changed?
I went and studied and I went and researched and I did what scientists are supposed to do. Look at the data, look at the evidence, look at the experiments. I found the evidence so compelling, it was almost like why wasn't I told about this? As a scientist, I now believe in a young earth and a divine creation of life.
So you need to tell us about some of these evidences that frame your scientific thinking now. Can you start to take us through some of those? Many scientists think that the evidence for an old Earth is so compelling that it's not even worth talking about. But I'm here today with a scientist whose thinking was turned upside down when he was challenged to consider the evidence. Dr Grocott, you're an industrial chemist with a PhD from the University of Western Australia in physical and inorganic chemistry. You've published around 50 papers in peer-reviewed journals, and you hold an adjunct professorship at a well-known Australian university. You went through your studies and your PhD as an atheist. But tell us what changed.
Yes, well, the change really started when I was doing my PhD. As you said, I grew up as an atheist. I used to believe in long ages and evolution because that's what I was taught to believe. I didn't really think about it. But for the very first time in my life, in my early 20s, I was challenged by a fellow PhD student who was a believer in recent creation and a young earth. And he asked some scientific questions, not theological questions, scientific questions that challenged my thinking, and I didn't have any answers.
What did you do?
Well, I'm embarrassed to say that I did nothing. And that's embarrassing because as a scientist, you're not supposed to do nothing when you're presented with contrary evidence. You're supposed to go and investigate. You're supposed to test, stress test, experiment, measure, read other research. I didn't do that. I flushed it. I flushed it from my thinking. It was an inconvenient truth, and I just dispensed with it.
But you're a scientist. You're supposed to be fact-based, evidence-based, driven by data. What was going on?
Oh, now you're increasing my embarrassment. Yes, scientists are meant to be fact-based and data-driven. And mostly what I did as a scientist and what most scientists do is fact-based, is data-driven. It's called observational science. You have a hypothesis. You frame an experiment, you conduct an experiment, you measure, you collect the data, and you test and you repeat, and you do all of that. Now, when it comes to origins and age of the Earth, these are not observational sciences because you can't go back and repeat the event. So why did I not go and do the research? Why did I not go and look at all of the data? Firstly and foremost, it was peer group pressure. I was concerned with what my peers might think. And you might think that scientists are not subject to peer group pressure. They are more subject to peer group pressure than your average person in the street. And that's particularly so in the academic community where the pressure to conform is huge because they depend for their grant success often on peer opinions and peer reviews. And so if they have a minority opinion or an opinion that conflicts with the majority, that threatens their very viability in their research.
So they want to keep their jobs and they don't want to lose the amazing reputation that they've probably built.
Yes, and so a lot of them do what I did. And they just say, okay, in my area of expertise, there are no answers or evidences in support of an old Earth, but I'm specialised in this field, so the answers must lie outside my field. And so you appeal to the discipline expertise or the narrowness of the discipline because most scientists they're an inch wide and a mile deep. And so it's very easy to say, well, the answer lies outside. They end up going in circles because, I'll speak to the physicist who'll say, well, the evidence is with the paleontologist, and who'll say the evidence is with the geneticist, who'll say it's with the biologist, who'll say it's with the cosmologist, who'll say it's with the chemist, and we've just gone back full circle.
Okay.
So everyone is appealing to somebody else, but nobody else is presenting compelling evidence. So that is one of the main excuses used by people like me when I was thinking in that way.
You then obviously went on a bit of a journey. So can you take us through the process of that journey?
Yes, well, as I said, it started during my PhD, and to my shame, I flushed this discomfort. I said, I'm not even going to go into this subject I don't like where it leads to. I don't like the implications of the scientific questions he is asking. So I set it aside. But the seeds had been laid. They slowly germinated. And about 10 years later, a wonderful man poured some water on this seed, and all of a sudden, germination happened. And I saw from a scientific perspective how the evidence that we see in the world, in the universe, in observational science, where you can test and repeat, fits much better with a young earth creation and a divine origin of life.
Was this initially a little bit jarring for you, a little bit uncomfortable?
It was literally a Damascus Road experience.
What do you mean by that?
That means it was out of the blue. I was not expecting it at all. But what it did make me think was that, wow, the evidence, the questions that I was asked that I couldn't answer, I suddenly now had answers. But I needed to learn as a scientist. I needed to learn an awful lot more about it because I knew how my peers, some of my peers who were believers in a young earth and a recent creation, I knew how they were criticized. I knew how they were ridiculed. And I had been discomforted by watching this because I saw them being attacked as people. But at no point did I see their science and the evidence being attacked. It was always ad hominem, attack the man, attack the woman, not attack the science. Now, if the science was so compelling in support of an old earth, then surely it would be easy to disarm somebody who's presenting contrary evidence. But I never saw that being done. And so the moment I came to understand that there was a young earth creation, I thought, if I am going to be attacked, I need to make sure I've got the answers to deal with this.
Yeah, wow. So as a scientist, what did you do?
I started studying and I started learning. Now, I was working as a scientist in industry in a fairly senior role and fairly busy. But in my spare time, I started reading and researching, and I found the evidence just so overwhelming and so compelling. It was almost like why wasn't I told about this? But really, I should have looked in the mirror and said, why didn't I ask about this? Because I just accepted. I was fed a spoon and I swallowed the spoon. I didn't look what was on it. I didn't look at the implications. I didn't look at whether the data was really there to support it. I just swallowed it. So I went and studied and I went and researched and I did what scientists are supposed to do. Look at the data, look at the evidence, look at the experiments.
Wow. So you need to tell us about some of these evidences that, I guess, frame your scientific thinking now. Can you start to take us through some of those?
Yeah, one of my favourite ones. I'll start with one of my favourite elements in the periodic table. That's helium. It's the second smallest element. Now, I like helium because, like most people, they've seen them in party balloons and events, and they're pretty cool when they float.
Yep, my children love them because they stay up in the air for longer.
Yep.
They don't like them when they start to lose the helium and disappear and back on the ground again.
They would like it even less if they were putting the helium in a normal rubber balloon.
Oh,
because
how come?
the rubber molecules are relatively far apart. And helium's really small, really slippery. It has what's called a high diffusivity, so it leaks out quickly. So if you put helium in a rubber balloon, it's flat and deflated in no time.
Right.
So if you bought helium balloons, you'll notice that they're rubber on the outside, but they're metallized on the inside, like there's a metal foil, because the metal atoms are closer together, and the helium can't leak out as fast. Now, helium leaks out easily, and it even leaks out of some of the most tightest packed things that you can get, which is mineral grains. And there's a mineral called zircon, and you can get helium in it, and it leaks out of zircon, and you can measure that rate.
Where do we find this mineral?
In rocks all over the world. Okay. And now, helium gets in there. So, how does helium get in there? Well, when you have a parent radioactive element and it decays through a process called alpha decay, you end up with a daughter element and you end up with an alpha particle. What happens to the alpha particle? The alpha particle is actually a helium atom with 2 electrons ripped off it. And it needs the electrons back. It just grabs them from anywhere near them, and the alpha particle becomes a helium atom. And so you end up with a helium atom in this zircon crystal. And the more and more of these radioactive parents decay to the daughter, you end up with more and more helium in there. Now, because the helium is leaky, and you can measure, this is observational science, you can measure the rate at which the helium leaks out of this, not the balloon this time, but the zircon, and you can say, okay, that's how fast it leaks. You can infer how much helium was there, because you can measure all the daughter elements, and each one of those gave off a helium.
Yep.
And you can say, okay, there's this much helium in there. How old is this rock? And you go, well, it must be thousands of years, because otherwise all the helium would have leaked out. If the rock was millions of years, the helium would have gone. So that is pretty compelling evidence. And this confronted me when this was presented to me. And I realized the only explanation that makes any sense for this is the rock is relatively young. Otherwise, the helium, like the balloon, would have, it's gone. So, young rock. Now, you say, wow, how would a long-age believing scientist who's intelligent explain this? They would not explain it using science. They would say, I believe the following things to be true. Mm-hmm. This rock is old and was not created. If the rock is old and not created, but you've got a lot of helium in there, then in the past it must have leaked out more slowly than it does today. No evidence. It's a belief system. Or some helium must have leaked in from somewhere. No helium in the surrounding rock. Where did it come from? So these are paradigms, these are beliefs that people choose to believe based upon a worldview, not based upon science.
But if you told them that's based on your worldview, that's not based on science, wouldn't they push back on that?
Mostly, yes. I'll use as a perfect example. One of my very good friends, after I came to the realization about all of the overwhelming evidence that was existing out there for a young Earth and a recent creation and a divine origin of life, he accompanied me on a 1.5-day scientific conference and seminar presenting all of the evidences, or many of the evidences, for a young Earth creation and a divine origin of life. And at the end of it, a day and a half, and he's a very good scientist, I said to him, so what do you think about this? His answer was, well, I cannot refute anything that has been said.
Well, that's a big call.
Yeah. He said, I mean, it's good on him for being honest. I cannot refute anything that has been said, but I just don't care anyway. So that's not science. That's a paradigm. That's a worldview. Now, as a scientist, I was uncomfortable with taking that position, though I must admit that's where I used to be as well.
So we've been talking about operational science, repeatable processes and testing that can be done, and helium as an example. Stephen, can you give us perhaps a geological example that the layperson might be able to understand?
Yeah, I certainly can. But firstly, as a chemist, I say the helium is a chemistry evidence, but a geologist will say it's a geology evidence as well, and a physicist will say it's a physics. So it's all of them. But a real-world, easy-to-understand example, geological evidence for a recent creation is folded rock strata. So rock strata are the layers of rocks that we see. You take a cross-section through a mountain or through a hill, or you're driving along a freeway and there's a cutting, and you see on the side, you see all of these layers of rocks. Now, there are plenty of examples in the world, but in Melbourne, where I happen to live, I drive along a freeway and there's a beautiful rock cutting through there. And you see all of these layers, and it's very, very nice. But the neat thing about these layers is some of them turn nearly 90 degrees over a distance of only about 30 meters, 100 feet.
But it's rock.
It's rock. It's rock. It's rock today.
90 degrees. How is it doing that?
That's right. It's rock today. And you say, well, how did it get bent? Did it get bent when it was rock? Well, you and I know. Common sense. Geologists know. Mechanical engineers know. Civil engineers know. Structural engineers know. When you bend a rock with something that has a high yield stress, it's going to crack. It's going to fracture. And at the microscopic level, the geologists and mineralogists can actually look at the mineral grains and they say, this has not been subject to stress. These crystals are not fractured. They're not melted from the friction. They're not distorted. So how did this collection of rock layers, which is supposedly at the bottom 0 years and at the top hundreds of thousands or millions of years of age, how did this rock bend? Clearly, there is only one explanation. It bent when it wasn't a rock. It bent when it was sediment, wet, moist, plasticine, putty, when it was soft. And you could bend these layers that had formed, and then it solidified to rock. So getting the sequence right is really important. So you say, how can this happen? An even more extreme example, I haven't been to it, but many people have, the Grand Canyon. You've got rocks down at the bottom that are dated in the old age time frame as being 250 million years older than the rocks at the top. But there are bends in these so-called 250 million years that show no fracturing, no faulting, no mineral distortion, no frictional melting, none of this. So how did they form? When they were wet, when it was sediment, before it had solidified. How do you explain this? Well, I have a really good explanation. It's called Noah's Flood.
Okay, but is there other evidence for Noah's Flood?
Oh, yes. Apart from the global catastrophism we see in sedimentary rocks all over the world and volcanism and ice ages explanation, I won't even go into that, but I'll go into a specific one. Noah's Flood would have buried vast amounts of vegetation, land, terrestrial vegetation, algae, and so on and so forth. That buried vegetation under the right conditions forms coal, oil, and gas.
Part of your professional career, you've been working in the energy sector. Is there evidence that you've learnt there that threatens long ages?
Absolutely. In fact, I worked on a project, it was a $1 billion project where we were taking the buried vegetation that was in sediments and digging up these rocks, and we were turning them into oil in 3 minutes. Not 3 million years or 300 million years, 3 minutes.
That's not supposed to be possible.
It's absolutely possible. We were doing it for a living and we were producing it.
How are you doing it?
There were planes flying around the world using that oil. Wow. So how will we do it? Now, the way we did it was under some very aggressive conditions that are not found in nature. So the temperatures we were using were higher than what you find in buried sedimentary rocks. But as a result of this process, I read a lot of research about oil formation, coal and gas formation. And I found there is abundant evidence, and this is included by long-age believing scientists, abundant evidence for how to turn naturally occurring vegetation and algae and buried organic sediments into coal, oil and gas. All it takes is a moderate temperature that you find in sedimentary rocks in some parts of the world, 250, 300 degrees centigrade, not that hot in geological surface systems. The right amount of water, there's plenty of water there, the right sort of minerals, certain common clay minerals that you can find in your garden, and you just leave them there weeks or months or a handful of years, and you end up with coal, oil and gas, depending upon the conditions you use. Weeks, months or years, not millions of years or hundreds of millions of years. That happens quickly. And the clincher, the icing on the cake, is there's evidence in oil basins around the world today where you see oil seeps, oil formation. You can carbon date this oil. Now, carbon dating, if you don't know about it, allows you to determine the age of something based upon carbon-14 to carbon-12 ratios, and you can extrapolate an age, and the long ages will extrapolate it to tens of thousands or maybe a couple of 100,000 years. So if oil took 10 million years to form, there is not a carbon-14 atom left. It's gone. It's all gone. There isn't any left. Now, the fact that you find significant amounts of carbon-14 in there says, hey, this oil's relatively young. It's not millions of years old.
Yeah. Wow. What are scientists doing? They know this kind of evidence. They've seen that this is happening or seeing that this is possible. How are they responding to this again? I want to know because it seems very clear.
After scratching their head, they say, well, I cannot allow a divine foot in the door. I cannot allow a young creation. Therefore, I must find an explanation for this carbon-14. Clearly, there shouldn't be any there. So it must be contamination. Must have come from somewhere else.
What do they mean by that?
So
what sort of?
In my laboratory, in the laboratory, the people were making the measurements. They must have introduced some young carbon in there. And that's where the carbon-14 came from.
Carbon.
It was contamination in my analytical chemistry process. That's been proven not to be the case. Very high quality work has shown no, that contamination doesn't occur. So then they say, well, it must have been contamination in the geological system. Somehow some young carbon got in there. Explain getting young carbon into something buried a few hundred meters. You can't do that. And then To make it even worse, diamonds, which are supposed to be millions and millions and millions of years old, and there's no way you can get new carbon into them because they are so tightly packed. There's carbon-14 in diamonds. So diamonds aren't millions and millions of years old either. How do they explain this? It's called an anomaly. And in some cases they say, we don't know the explanation yet, but I'm sure we will find it eventually. That's a faith-based position.
Yeah, that sounds faith-based. They don't know yet, but they're going to say this anyway.
And I contend, not everyone would agree with me, but I contend it takes an awful lot more faith to believe in this unobserved events and influences than a young creation. It fits the data so much better. And as a scientist, that sits better with me. If I have no preconceived ideas, a young creation fits the data far, far better. It takes more faith to believe in an old Earth than a young Earth as a scientist.
Wow, that's a big statement. Can we have some more evidence? Can you give us something else, Stephen?
Yeah, I'll use one that's of current interest to me. Part of my current research is involved in battery chemistry and lithium-ion batteries, which we use in our smartphones and PCs and electric scooters and electric vehicles. So a lot of those high-energy batteries use a high-purity form of nickel. So I'm quite interested in nickel chemistry. Now, you find nickel in some minerals, but you also find a little bit of nickel in the ocean. And you say, well, how does the nickel get into the ocean?
Yeah.
Well, it gets in there from rivers and groundwater and runoff. And so nickel enters the ocean at a certain rate, which we can measure. Now, nickel leaves the ocean at a smaller rate. We can measure that too with sediments and salt sprays and things like that.
Yep.
So the amount of nickel going into the ocean is greater than the amount of nickel going out. So every year you get this much more nickel.
Okay.
And if you look at the amount of nickel in the ocean today and you say, well, how long would it have taken to get there starting at 0 nickel? And you can calculate it's thousands of years. That's all it takes to get to today's nickel concentration. Now, if the oceans were billions of years old,
Which they say,
even if the ocean was a couple 100,000 years old and you've accumulated nickel at this rate, your ocean would be too toxic. It would exceed environmental limits for marine life. So you would have a toxic ocean. And if you go back 1 million years or 10 million years or 1 billion years, it's so toxic. If you had a fish, it's a dead fish.
Yeah.
Too much nickel.
So what about some examples that we can actually see?
So examples that we can see. I'm going to use dinosaurs. And you say, well, we don't see dinosaurs today, but people have recorded in art, in oral history, in writing, with beautiful descriptions of what we now call dinosaurs. Now, the word dinosaur was not created until the 1600s. Prior to then, they were called dragons or other names in the local languages. But you can go to a church in the UK, there's a brass inlay which has got a dinosaur in there, along with other things that exist today, not fictional animals.
But dinosaurs are supposed to have died out 65 million years ago.
Yeah, that's what I was taught. That's what you were taught, and that's what most people are taught.
So how is this possible that we have these recreations and descriptions from
Because
humans?
they didn't die out 65 million years ago and people saw them and wrote them down. You can go to a church in Georgia. You've got carvings on there. You can go to Cambodia, Angkor Wat. There's a stegosaurus there. One of the neat personal examples, my wife and I were holidaying a few years ago in the beautiful capital of Estonia, Tallinn. We're walking down a street, a narrow alleyway with centuries-old buildings either side of us with carvings in the stone. And I'm walking past and I go, there's a sauropod dinosaur carving in the wall, along with everything else that is real. It's not fictional. Take as another example. The Chinese years. You've got the year of the horse and the rat and the monkey and so on and so forth.
All these animals that exist today.
11 of them that all exist today. And nobody says they're fictional. And there's the year of the dragon. And the dragon is a description of a dinosaur. So why would we think that they slipped in one fictional one that they hadn't even seen?
Doesn't seem to make sense.
Doesn't make sense. So 11 real and 1 false, 12 real makes more sense. So these are observations that we make today.
So you're saying that dinosaurs didn't die out 65 million years ago if we have all this evidence of connection with them and human beings. What about some other living examples?
I'll talk about the complexity of living organisms. So, and even before you get to living, some of the complex molecules that are contained within living organisms are so mind-bogglingly complex, it is barely even possible to describe them. So take some simple peptides or proteins or polysaccharides or lipids or other complex chemical structures that are supposed to have formed by chance. And you look at the chemical thermodynamics, the probability theory, the chemistry that goes into the formation of these, they are so complex, it does not happen by chance. You can calculate the probabilities and it's off scale, 1 in a chance of 1 followed by thousands of zeros. That's classified mathematically as impossible. Complex organisms do not arrive by chance.
But it's the basis of their whole theory, is that they are.
It is the basis of the whole theory, and that is what we're taught. But when you look at the empirical, historical, observational science, it does not stack up. Because I can measure the probability of combining 2 amino acids to make a dipeptide and 3 to make a tripeptide. But, by the time I'm getting up to 50 to make just a medium-length protein, polypeptide, I'm now talking about probabilities that are less than 1 chance in the number of electrons in the universe. And this is science. This is thermodynamics. We learn this as undergraduates in school, and in some schools you even learn a little bit about it in high school. This is firm foundation science. You can measure the probabilities. Even under the most perfect primordial soup, you cannot form these complex molecules.
I feel like this complexity is all around us. As you say, we learn it at high school, we see it. Can you give us some other examples of this?
Yeah, and I've barely even got to the surface of it, but this is one thing that is really neat, and it was part of my PhD. There are some molecules that are called optically active. Let me explain that. It's a bit like our hands. I get a left hand, I get a thumb, index finger, and so forth through to my little finger.
Yeah.
And I got a right hand, thumb, index finger through to my little finger. So they're not the same though, because I can't put them on top of each other because they're not identical. They're mirror images.
Yep.
And a lot of biological molecules come in left hand and right hand. Now, when I, as a scientist, as a chemist, try to make molecules which are optically active, they come in left and right-handed forms. When I make them from simple chemicals, I get a 50-50 mixture because their chemical properties are identical. Same boiling point, same solubility, I'll get technical, same dipole moment, same bond angles, everything's the same. They're just mirror images of each other. So I end up with a 50-50 mixture. Okay, boring, Stephen. What's the significance of that?
Yeah.
Biological systems, proteins made of amino acids, where the amino acids are optically active, they're all left-handed. You don't find right-handed ones in there. So in this 50 amino acid polypeptide, they're all left-handed.
How do you know they're left-handed?
Because you can measure it.
Okay.
Yeah, this is testable, observable, measurable.
Yeah.
The rotation of the plane polarized light rotates it left-handed. This is getting technical, but you can measure it. People don't need to understand it. You can measure left and right-handed molecules.
Okay.
Now, this polypeptide, 50 left-handed ones. If I substitute a right-handed one in there, it becomes dysfunctional. It doesn't work as well, or in many cases will actually kill the organism because it doesn't fold the right way, it doesn't react the same way. It's just like I can't put my left hand into a right-handed glove. It won't fit. It's the same. You put a right-handed amino acid in there, it no longer fits. Yep. It doesn't fold in the right way. So, I've got to twist my hands in another way. If I want my thumb on there, I got to do something really difficult.
Yep.
And it doesn't work in biological systems. So, how do you get only left-handed ones from this 50-50 mixture? We can't do that as scientists. The only way you can even get close to it is through carefully controlling the environment through a lot of complexity. This takes a designer, a supreme intellect, far greater than what we have as human beings.
So with so much evidence for design, a designer, and a young Earth, why do you think so many people claim that we are not designed and the Earth is billions of years old?
Well, I guess one of the main reasons is that most scientists and most people don't actually know what science is. I mean, there are two types of science. There's the observational, operational science that we experience in our life. You know, this microphone, the table, you know, AI, new drugs, chemical processes, etc. Operational, observational science. There's a forensic and historical science, which is based upon assumptions about the past. So that sits outside of operational science. It's not provable. So people assume that there are explanations. They don't actually see the explanations for an old Earth. They just assume it's there. The other reason is because, let's be frank, and this is the case with me, people don't like the implications of things like a young Earth and a designer.
Why not?
Well, I didn't want there to be a designer, because if there was a designer, if there was a creator, the creator owns the creation. And I tell you what, I didn't want anyone owning me. I had my own life plans, and I didn't like the idea of somebody else having an influence over me. So that is not a scientific perspective. That's a worldview, because people make the mistake of thinking that science says this. Science doesn't say anything. It doesn't say anything more than a knife cuts something. A knife doesn't cut something. Somebody holding a knife cuts something. Science doesn't say anything. A scientist using science says something. And in that saying something, there are presuppositions, there are assumptions, and there are paradigms, and there are, I don't want to hear that. That's not a valid question. I don't accept that question. Ask a different question. Or I don't have the answer, but somebody else will have the answer somewhere else. So it's a paradigm. It's a belief system. And sometimes people are uncomfortable with the answers. I was uncomfortable with the answers where this was leading me, which is why it took me 10 years to come to realization that I was on the wrong train.
Well, it's a really important point to, first of all, make that distinction between those two types of sciences. But also just hearing you say the science is, it's like that's a magic word, you know, when people say, oh, well, it's science. But to first of all understand what it means, and then to say it's not what actually, can you say that again for us, Stephen?
Yeah.
What did you say? Science?
Science doesn't say anything. Scientists say things. Science does not stand by itself. It sits in a belief system. For a start, it sits in the belief that things always stay the same. That if I conduct an experiment today and under identical conditions I conduct it tomorrow, that I'm going to get the same result. If I measure the boiling point of water at the ocean in Brisbane, I'm going to get the same temperature, the same boiling point if I measure it somewhere else in the world at the same atmospheric pressure. So it assumes a repeatability in the universe. It assumes that there's no spurious outside forces. So science doesn't say anything. You have to believe a whole bunch of things, and you use science coupled with your belief system to make inferences about the past.
You interpret what the science is showing you.
And based upon all of the data and all of the evidence I've seen of the two hypotheses, it happened by accident or it happened by a divine creator, it is much more consistent with the data to believe that there is a young earth creation and a creator that fits the evidence far, far better than the faith it takes to believe that it happened by accident over billions of years.
So, Stephen, just to circle back to where we began, has this change in your scientific understanding actually affected your career at all?
From a purely technical perspective, no, not in any way at all. Zero influence, because I work in the field of operational science, hypothesis, experiment, observe, measure, repeat, often publish to make sure that the world can repeat it and verify it. So in the world of operational science, no, it doesn't make any difference whether the world was created by the flying spaghetti monster or all by itself or by the divine creator of the Bible. It doesn't affect the operational science that most scientists do. So from a purely technical perspective, no. There's a minority of scientists whose professions are affected by that belief system. But as a human being, it has made a huge difference. Firstly, as a scientist, I see and appreciate much more beauty in science than I ever saw before. I have, even today, after 40 years working as a scientist, I go, wow, that is so cool. That is so neat.
Why do you think you didn't have that before?
I used to like it and enjoy it, but I didn't get the buzz. Now I say, because now I know there's a divine hand behind it. There's a supreme intelligence. Instead of the laws of nature running itself, who created the laws of nature? And so I have this deeper appreciation and enjoyment for it. So as a scientist, I enjoy my science a lot more. It doesn't affect the science that I do or the way I do the science, as I've already said. So as a human being, as a scientist, I appreciate science much more. And as a human being outside of science, boy, has it made a difference, because now I know where I'm going to spend eternity, and that makes a big difference.
The word purpose comes to mind. Does that change things, knowing that a divine creator has created things with a purpose?
You bet. I mean, before I used to look in the mirror and there was my purpose. And now I know there is a lot more purpose to my life and to our existence than there is then to be just a simple scientist trying to make a very good living and enjoying the fruits of the blessings that I had through my parents and through my education and through being lucky enough to be born in this country. There's a lot more purpose and a lot more sense of value and a lot more enjoyment knowing there's a lot more to it than a random collection of pond scum turning into human beings and then dying for no reason.
Stephen, this has been quite a journey. What if someone else wanted to go on this journey as well? Is there anything that you could recommend that would help them?
Yeah, it has been a journey. It's been an intellectual and an emotional journey, and we shouldn't divorce the intellection from the emotions. Both are important. But in terms of my journey as a scientist, one of the best sets of resources I've ever found is the Creation magazine published by Creation Ministries. It is phenomenal. In the hands of a layperson, there are scientists who will not be able to refute anything that's in there. This is high-quality science expressed in the lay way. It is a great publication. And I'll use as an example one of my sons who went through what is often a normal period of teenage and early adulthood rebellion, and as we all struggle with life as we go through that age, he said to me some years ago, he said, Dad, I could never stay away from God because through the creation and evolution debate and through these sorts of resources, I have seen far too much to be able to refute the existence of God and a young earth.
The Creation magazine that Stephen just mentioned is available at creation.com, or you can go to the link in the description below. Stephen, thank you so much for your time today. It's been fascinating.
Thank you very much. It's been a lot of fun.